three sides are 1 meter length. So it is an E electric field. So what is the dipole moment? 4 into 10 power minus 9 are placed at A and C. So at A you have 9 nanocoulomb. Find the electric field as well as potential. So the resultant electric field is 9. Hello students, this is SD Sir again from the Temple of Excellence, Vidhyaashram Pre-University, Mysuru. Again, continuing our journey on numericals. Yes, we will again do it from the chapter Electric Fields and Charges. Hope you have gone through my previous 2 sessions on this chapter, solved the problems meticulously and come prepared for today's class. The first problem, students, a positive charge of 10 microcoulomb. There is a positive charge of 10 microcoulomb placed 1 meter away from a similar negative charge. From a similar negative charge. Calculate the electric field at a point 1 meter away from each charge. Very interesting. Follow here. A positive charge of 10 microcoulomb. 10 microcoulomb is placed 1 meter away from a similar negative charge. So to construct the diagram, so I consider 2 points, A and B. Positive charge of 10 microcoulomb is at 1 meter distance from a negative charge of minus 10 microcoulomb. 1 meter distance from a negative charge of minus 10 microcoulomb. I have to calculate electric field at a point 1 meter away from each charge. So, at a point C, which is 1 meter away from each charge, I am calculating the electric field. Triangle na observe madi. All 3 sides are 1 meter length. So it is an equilateral triangle. Where am I calculating the electric field now? At the point C. I am testing the electric field at the point C. So what has to be placed there? UPC. So UPC is placed at the point C, exactly as we did in our previous problem. Wherever we are calculating the electric field, testing the electric field, place a UPC. How do we do that now? First, I will calculate electric field at C due to this charge at A. I call that E1, which is electric field at C due to the charge at A. So this is 1 by 4 pi epsilon naught Q1 by R square, or E1 is 9 into 10 power 9, 10 microcoulomb, 10 into 10 power minus 6, distance is 1 square. So E1 is, so this is 9 into 10 power 4, 90 into 10 power 3, or 9 into 10 power 4 Newton per coulomb. What should be its direction now? At A, positive charge. At C, UPC, again positive. I have taught you all to write the direction. Both of them are positive. Like charges, they have to repel. So it will act away from the charge, experiencing the intensity. Who is that? UPC. So E1 should act away from C. Similarly, E2, electric intensity at C due to the charge at B. Again, 1 by 4 pi epsilon naught Q1 Q2 by R square, or this is negligible. 9 into 10 power 9. Again, 10 into 10 power minus 6. 1 square. 9 into 10 power 4 Newton per coulomb. What is its direction now? At C, positive charge UPC. At B, negative electric field lines. They start from the positive charge and end on the negative charge. So start from positive, end on negative. This is E2. Now, how will I find the resultant electric field? Good. There are two vectors, E1 and E2, acting at a common point C. Can I not use the parallelogram law of vector addition? Construct a parallelogram here. Diagonal of the parallelogram will give me the resultant. So this angle is theta, this angle is alpha. So expression for resultant, E is root E1 square plus E2 square plus 2 E1 E2 cos theta. We have done all these things in our session, or you are familiar. Expression for resultant of two forces acting at a point. What is theta here? If you observe, it is the angle between E1 and E2. And it is an equilateral triangle. So 120 degrees. And all of us know cos 120 is minus half. So on substitution, E is 9 into 10 power 4 whole square plus 9 into 10 power 4 whole square plus 2, 9 into 10 power 4, 9 into 10 power 4 minus half. And on simplification, this simplification is your task. Pick up your calculators. 2 and 2 gets cancelled. It is very simple. So this turns out to be 9 into 10 power 4 Newton per Coulomb. So the resultant electric field is 9 into 10 power 4. So this justification of theta is important. If you observe the diagram, it is angle between E1 and E2. No, it is equilateral triangle, 60 plus 60, so 120 degrees. Now what is alpha? E1 sin theta, E1 plus E2 cos theta. So if you remember, or this can also be written as E2 plus E1 cos theta. So on simplification again, sin 120, sin 90 plus 30. So this turns out to be alpha is tan inverse so much. So alpha is 60 degrees will be the answer. You get alpha is tan inverse root 3 for this, which is 60 degrees. So students, just by simplifying steps, you arrive at the answer. Next one, students. Similar problem as we have done earlier. Two positive charges. Now both of them are positive charges. 9 nanocoulomb and 4 nanocoulomb are placed at the points A and C respectively of a right-angled triangle. Very clearly it is mentioned now. It is a right-angled triangle. Where? Again he says clearly, angle B is 90 degrees. AB is 3 centimeter. Base A is 2 centimeter. Find the magnitude and direction of the resultant electric field at B. Now the given triangle is a right-angled triangle where very clearly B is the right angle according to the problem. So this is A, this is C. 9 nanocoulomb and 4 nanocoulomb are placed at A and C. So at A, you have 9 nanocoulomb. This is 4 nanocoulomb. How much is the distance AB? 3 centimeter. So AB is 3 centimeter, which is 0.03 meter. And this is 0.02 meter. Where am I calculating the electric field? At the point B. Again, what is placed at the point B? UPC. Because we are again testing the magnitude and direction of the electric field at this point B, as we did in the earlier case. First, electric field at B due to the charge at A, E1 1 by 4 pi epsilon naught Q1 by R1 square. Again on substitution, 10 power 9, 9 nanocoulomb. So this is 0.03 whole square. So effectively, it again turns out to be 9 into 10 power 4 Newton per coulomb. Again, what is the direction? B ಯಲ್ಲಿ positive charge ಇದೆ. A ನಲ್ಲಿ positive charge ಇದೆ. Again, repulsion. So field should act away from the charge experiencing it. Who is the charge experiencing? UPC. So this is the direction of E1. Similarly, field at B due to the charge at C, E2 1 by 4 pi epsilon naught Q2 by R2 whole square, 9 into 10 power 9, 4 into 10 power minus 9, 0.02 whole square, which is again 9 into 10 power 4 Newton per coulomb. Again, direction. Now, this is the direction of E2. Again, how will I find the resultant electric field? Same as we did in the previous problem. Parallelogram law of vector addition. Construct the parallelogram from the point of application, direction of the electric field. This will be alpha. Again now, resultant field is root E1 square plus E2 square plus 2E1 E2 cos theta. What is theta in this case? It is a right angle triangle, 90 degrees. So cos 90, 0. So effectively that expression becomes root of E1 square plus E2 square. 9 into 10 power 4 whole square plus 9 into 10 power 4 whole square. So this is again 12.7 into 10 power 4 Newton per coulomb, and this is the direction or the magnitude of the resultant. What is alpha again? Since theta is 90 degrees, E2 by E1. So E2 by E1 is 1. Tan inverse 1. So alpha is nothing but 45 degrees. So the direction of the resultant is 45 degrees. The next one. An electric dipole with dipole moment 4 into 10 power minus 9 coulomb meter, aligned at 30 degrees with the direction of uniform electric field of magnitude 5 into 10 power 4 Newton per coulomb. Calculate the magnitude of the torque acting on the dipole. What is the expression for torque, students? So tau is P E sin theta. Again, a proper glance on the chapter, a proper glance on this session. Very clearly you come to understand tau equals P E sin theta, where P is electric dipole moment, E electric field. So what is the dipole moment? 4 into 10 power minus 9. So torque is 4 into 10 power minus 9. Electric field 5 into 10 power 4 sin 30, which is half. So on simplification, the answer is 10 power minus 4 Newton meter. So this is half. This goes twice. 10. Yeah. So torque is so much. 10 power minus 4 Newton meter. This is a 2 marker that may be asked in the exam. This is an assignment problem for you. I've already done this in the previous session. I want you all to solve this. 2 tiny spheres carrying charges plus 1.5 microcoulomb. Q1 is given and plus 2.5 microcoulomb Q2 is given, are placed 30 centimeter apart. Find the electric field as well as potential at the midpoint of the line joining the 2 charges. Separately, in the potential chapter also I have worked out this. The second session of this chapter also I have worked out. You amalgamate and solve. So students, in today's class, we have worked out few important numericals from the chapter Fields and Charges. We will continue in our next session. Until then, have a nice time. Thank you.